Example of where we're optimizing is on how we provide you, the customer, a consistent, reliable experience. Now, if you take a look at different AI workloads, they fit into one of these four categories generally. In terms of the number of prompts, tokens in the prompt versus the number of tokens that are generated by the AI model processing that prompt. So you can see there on content creation, it's prompt light because it's like, go write me a story or go write me a Word doc about X. And it's generation heavy because you get a lot of output in return. On the bottom right, you have generation light and prompt heavy because you're giving it like a whole document and saying, summarize this for me. So lots of prompt in, few response out. And these types of generation are very different. Prompt processing happens in parallel, can happen very fast. Token generation, the response, happens slowly. It's one token at a time because you need to generate the token, then add that back to the context, and then predict the next token. And this happens one token at a time, so very sequential. So the naive way to schedule this is to take the prompt tokens in, process them all in a big chunk, keep this GPU busy doing that, and then start to do generation. Now, if you have a second prompt come in, it's going to do all that prompt processing, and that's going to start interfering with your generation of the first prompt. And then the combination of the generation of those prompts, the generation off those prompts is also going to be slower because you're having them interfere with each other. So we started something called Project Flywheel to look at optimizing this because the effect is very inconsistent performance. And with Project Flywheel, we take the prompts in, we batch them, so we only do a fixed amount of them at a time. We generate at normal speed. We have another prompt come in. It's also doing batches, so it's not allowed to interfere with the prompt generation of the first prompt, or the response generation of the first prompt. And you can see then we get consistent performance. And this is what is allowing us to introduce now fractional provision throughput units. So instead of basically provision throughput units for the whole GPU, you get fractions because we're able to provide this and give you very predictable performance. So let's see a demo of Flywheel in action. And at the top, you can see this is a system here. Each of those little colored boxes is a different either prompt or response generation. The larger blocks, as you can imagine, are prompts. The smaller ones are generations. And there's a bunch of different workloads competing with each other. And you can see the latency is going to be very variable on your prompts per second. Whereas the bottom, when we use Project Flywheel to chunk them so that they're in fixed size batches and we can control the execution, we get very predictable performance. And to demonstrate that even further, here I've got three workloads. One that is very prompt heavy and light generation. One that's balanced, which most workloads, like a chat workload. And then on the right, you can see small prompt, large generation, like summarization. So light, balanced, and heavy on prompt size. And you can see I'm sending requests into all three of them. We're going to take a look at PTU performance here in Grafana. You can see the consumed PTUs at the bottom. Each workload is given a different, you can imagine, you can kind of already figure out, prompt tokens per minute. The green line is the one that's prompt heavy. Lots of prompt tokens. And you can see the yellow is medium, and the green is light on prompt, heavy on generation. You can see the generated token per minute. It differs across them, but across all three of them, we're able to provide very consistent throughput for all three of them, which means if you understand your workload, you can understand how it's going to behave. And the same thing when we scale PTUs on that medium job, you can see that the prompt tokens per minute scales linearly as we give it more capacity. And the same thing happens for tokens per minute, but we're able to keep the time between tokens 100%, basically 100% consistent. And so this is the key to really providing serverless AI serving with you understanding exactly what you're going to get and doing it very efficiently. We're able to have multiple prompts being processed on the same GPU. So